Hi Calc AB. This is page 63. The functions f and g are differentiable for all real numbers, and g is strictly increasing. The table above gives values of the functions and their first derivatives at selected values of x. The function h is given by h equals f of g of x minus 6. So one thing that I see when I read the text is that the very first few phrases here are really important. The functions f and g are differentiable, and the fact that they're differentiable means that those two functions are continuous. Part A, explain why there must be a value r for 1 less than r less than 3 such that h of r is equal to -5. So when I read that, I immediately think intermediate value theorem, because here is a problem where we need to show that this output is possible. So I'm going to write my conditions of my theorem. We know that f and g are differentiable, and that implies that f and g are continuous. Therefore, h, which represents a composition of continuous functions, is also continuous. So now our job is to figure out what h of 1 is, and we need to figure out what h of 3 is. And our hope is that one of them is going to be greater than -5 and the other one is going to be less than -5, and that way we can show the betweenness. So h of 1 is f of g of 1 minus 6. G of 1 is 2. F of 2 is 9. So 9 minus 6 is equal to 3. H of 3 is f of g of 3 minus 6. G of 3 is 4. F of 4 is -1. And so then this is -7. So our conclusion is this. By the intermediate value theorem, since -7 is less than -5 is less than 3, there exists an r in 1, 3 such that h of r is equal to -5. Part B. Explain why there must be a value c for 1 less than c is less than r such that h prime of c is equal to -5. This one sounds like MVT to me, the mean value theorem. So we've already stated that f and g are differentiable because that was in the text. So we can use the theorem because differentiability, which is what we need for that theorem, is already existing. We also know the outputs. The outputs for h of 1 and h of 3 were found in part A. So let's find the average rate of change for those h values. So we'll use -7 minus 3 all over 3 minus 1 is -10 over 2 is equal to -5. So our conclusion will be, by the mean value theorem, there exists a c in 1, 3 such that h prime of c is equal to -5. Part C says, let w be the function given by the integral from 1 to g of f of t dt. One thing I want you guys to notice are that these variables are different, and that's really important. So as you guys are asked questions on the free response, make sure that if you're writing general integrals like this, that you have different variables, should the problem require that. The question says, find the value of w prime of 3. So we need to find the derivative of this and then evaluate it at 3. So I want you to remember that the fundamental theorem of calculus says that you can evaluate the antiderivative up high minus the antiderivative down low. And then you can differentiate every single part of this phrase. So w prime of x will be equal to big F prime of g times g prime, and that's because of chain rule. The next piece right here is just a number. It could be 7, it could be 82, but when you take the derivative of a constant, you end up getting 0. So you'll subtract 0. And now you make a connection here that the derivative of an antiderivative gets you right back to that inside function. So this is f of g times g prime of x. That's why the variables here being on the inside being different matters, because this function can be changing while this one can be input. So it's a big deal. W prime of 3 equals f of g of 3 times g prime of 3. Now you can go back to the table, and g of 3 is 4. G prime of 3 is 2, and f of 4 is equal to negative 1. So we have negative 1 times 2 is negative 2. And the last part, letter D, if g inverse is the inverse function of g, write an equation for the line tangent to the graph of g inverse at x equals 2. I'm going to make this little substitution because I think that this is something that we've used throughout the year, that it's easier to think about taking derivatives of m rather than the derivative of g inverse, just because there's like a lot of different things happening like right here. Okay, so we know that g of 1 is equal to 2, therefore m of 2 is equal to 1. I think that's an important step to take. How did I know to do g of 1? And it's because the question asked me for the line tangent to the graph of g inverse. And we know that the inputs here, the inputs into the inverse, are exactly the same as the outputs in the original function. And the output here is exactly the same as the input into the original function. So that's an important relationship to remember. The table gives us information about g prime. So g prime of 1 is equal to 5. And one of the things that we studied is that this derivative should be the reciprocal. You should be able to multiply these values together and get 1. All right, so at this point you're ready to build the tangent line because you've got the point and you have the slope, and you're all basing it on the inverse function because that's what they asked you to find the line tangent to. So your tangent line will be y minus 1 equals 1/5 times x minus 2. And that's it for page 63.